Hello, y'all. Welcome to lesson 75 of my DP chemistry curriculum. Today we're going over reactivity 1.3.4. We're going to talk about biofuels, how they're produced from the biological fixation of carbon over a short period of time through photosynthesis. We will, by the end of this, understand the differences between renewable and non-renewable energy sources and consider the advantages and disadvantages of biofuels. It's a pretty short unit, but a lot of small things to cover, so let's see if we can get right on to it. So let's start talking about renewable versus non-renewable energy. This is a pretty hot topic in the world right now, so we should know what we're talking about when we're discussing each. When we talk about renewable, it's quite literally as it says. It can be replenished. And more importantly, it's at the rate it is used. So it can theoretically be replaced as fast as we use it. Some great examples of renewable are hydro. I'm in BC, Canada right now. We have a lot of hydro, tidal energy. That's always a pretty interesting one. Solar is really big and a great example. We'll actually go into it a little bit. In addition, we also have wind energy, geothermal. I believe Iceland's really big on geothermal, and then uh, we also have biofuels. This is the name of the unit, so we're going to return back to that one in just a moment. In addition, we have non-renewables. As the name suggests, these are consumed, so they can be exhausted, cannot be replenished, maybe not at the rate, but cannot be replenished as fast as we use them. So these are pretty much what we're referring to when we talk about things like fossil fuels. Now, another weird one in this category that we don't often think about is also nuclear. Nuclear is a great energy option. It's actually very safe, contrary to popular belief, and it also produces a lot of energy. And compared to the waste of like fossil fuels, it's quite minimal. But it is non-renewable because we cannot suddenly make more unstable uranium that we might be using for nuclear energy. Um, with that said, let's return back to biofuels, the main topic of this. So, what the heck are biofuels? As the name would suggest, they come from biological sources. Biological sources. That's where the whole name comes from. And they actually start a little further up a little further up, not the food chain, but there's definitely a word for this. It's the trophic levels. They come from the higher trophic level because this starts at the sun. Kind of like solar, honestly. This is what I was referring to. With electromagnetic radiation, which is essentially just light. So this electromagnetic radiation, this light, gets absorbed into plants. And in plants, it's used to convert CO2 and H2O, so carbon dioxide and water, straight into glucose and oxygen. This process is known as photosynthesis. So 6 CO2 plus 6 H2O, this is a reaction you should have memorized, turns into C6H12O6 plus oxygen gas. This is what is referred to as photosynthesis. And the wild thing is, if you look at this reaction backwards, oxygen plus glucose becomes carbon dioxide and water. This is just combustion. And another weird thing is this is what happens in your body. When your body reacts glucose, sugar, with oxygen that you breathe and turns it into water and carbon dioxide, we get energy out. We actually get the exact same amount of energy out that has to go in because this is the reverse reaction. So, in addition to being combustion, this is what you might think of as aerobic respiration. So, one other quick clarification is this right here is glucose, C6H12O6. Now, in plants, the glucose is also used, and it's used to build structures like create cellulose, yep, starches. It can be rearranged to make lipids, polysaccharides, a lot of things. So plants use this glucose too. But these hydrocarbons that we get, these larger ones, and lipids, we can combust for energy. We can also combust the glucose on its own, but normally when we're talking about biofuels, we're talking about combusting these larger hydrocarbons. So these are what biofuels are. And there's some distinct advantages to them. First off, when we create modern biofuels, so modern biofuels, what we do is we take these compounds and we process them. So these are processed hydrocarbons. And we turn them into short chain hydrocarbons. Short chain hydrocarbons and alcohols, even esters sometimes. And these combust even easier than these large structures like cellulose and starch. And not only do they combust easier, they combust more completely because they're shorter. We talked about that in our previous video. So let's talk about our advantages of biofuels. First off, you'll notice that the process to create biofuels absorbs carbon dioxide. So one of the main advantages is it offsets itself, offsets carbon dioxide from fossil fuel burning. So that's great because we're absorbing CO2 from the atmosphere. Furthermore, like we mentioned up here, these short chain hydrocarbons are more readily combustible, easily easily combusts completely. And that's because we process them into more easily handleable biofuels. Furthermore, refining, so that process of making them better, and synthesizing is less harmful than refining fossil fuels. So it's always going to be better than refining a fossil fuel, much less harmful to the environment and even to those in the factory or whatever. Furthermore, this is inexpensive. Overall, biofuels are relatively pretty cheap. So one of the other things is we can use them straight away as well if we want. They can be used without processing if needed. Now, along with advantages, of course, we're also going to go over a couple disadvantages. With biofuels, one of the big things is to grow these fuels, you need suitable, I think there's an I in there, suitable agricultural land. Land that can be much better suited to a million other things. You still have to burn it, so it's still combustion, and combustion releases, oops, releases CO2. And if you think about it, you're actually going to get the same amount of CO2 that you put in to make it. So it's not adding any extra like the fossil fuels are, but it's not really actively taking away fossil fuel, or it's not actively taking away CO2 because it'll come right back out. Furthermore, the growth still currently relies on fossil fuels. So the way we grow these agricultural crops for biofuels, we still have to put fossil fuels in for the machines that we use, for generating electricity to power the farms and power the pumps and all that stuff. So it's still not a perfect system. But these are some of the main things you need to be thinking about when talking about biofuels. Anyways, I hope this helps and have a great day.